So here in this problem, we are provided with four numbers A, B, C, and D, and these four numbers are in harmonic progression. So we need to verify the following inequality using the idea that A, B, C, D, and D forms a harmonic progression. So let's begin with proof number 1. So here, in order to prove number 1, so we'll start with the first three numbers in the sequence. That means A, B, and C. These three sequences are in harmonic progression. Fine. If they are in harmonic progression, then this would imply that B is the harmonic mean of the two numbers A and C. But we know that the arithmetic mean, which is denoted by A, for the two numbers of A and C, that's simply A equals to A plus C over 2. Also, we are aware of the property that states that the arithmetic mean is always greater than the harmonic mean. So that means A plus C is over 2 is going to be greater than the harmonic mean, which is nothing but B. Now that means we have A plus C. All we are doing is multiplying both sides of the inequality with 2. So A plus C over 2 will simply become A plus C, and B will become 2B, but 2 being a positive number, so the inequality sign remains unchanged. We're going to label this as number 1. Next, what we'll do, we'll consider the case that this time we have B, C, and D. So these three terms are in harmonic progression. So if they're in harmonic progression, that immediately tells us that C is the harmonic mean of B and D. But we know that the arithmetic mean, which is going to be denoted by A, of B and D is going to be given by A equals to B plus D over 2. Again, applying the same property that A is greater than H, we have the arithmetic mean B plus D over 2. That's going to be greater than the harmonic mean, which is simply C. So we have B plus D greater than 2C. So let this be number 2. Now what we'll do, we're going to combine 1 and 2. Combining 1 and 2 means we're going to add inequality 1 with inequality 2. So we're going to first combine the left hand side of the inequality. So A plus C will be added to B plus D. And this is going to be greater than 2B plus 2C. Now what we can do, we can subtract B and C from both sides. So we have A plus C plus B plus D. What we'll do, we'll subtract B and C from both sides of the inequality. So we have 2B plus 2C minus B minus C. So here, positive C, negative C, positive B and negative B goes away. So we are left with A plus D greater than the 2B minus B, that's going to be simply B, and 2C minus C, that's going to be positive C. So we have proved the first inequality, that A plus D is greater than B plus C. Moving on to the second part of the proof. So here we have to prove the inequality AD is greater than BC. So let's begin with number 2. So we'll start with the given condition that A, B, C, and D are in harmonic progression. So that's given to us. So from here we can only pick up the first three terms. So A, B, C are still going to be in harmonic progression. So if A, B, C are in harmonic progression, then the harmonic mean is simply going to be the middle term, which is B. Fine. This is the harmonic mean, but we know that the geometric mean of A and C will be square root of AC. And we know that there's a property that the GM, the geometric mean of two numbers, is always greater than the harmonic mean, which means that square root of AC is going to be greater than B. So we're going to label this as number 1. Then we again start with the given condition that A, B, C, and D are in harmonic progression. So if they're in harmonic progression, now we'll consider only the last three terms. So that means B, C, and D are also going to be in harmonic progression. And the harmonic mean is now going to be denoted by the middle term, which is C. But the geometric mean of the numbers B and D, so that's simply going to be equals to square root of BD. And using the condition that since the geometric mean is always greater than the harmonic mean, so here we have square root of BD comes out to be greater than C. So let this be number 2. Now what we'll do, we'll take the product of 1 and 2. So we get square root of AC times square root of BD. This will be greater than BC. Now here we have to be careful. We are considering the case that A, B, C and D, these all 4 numbers are positive. They are positive number. Only then the sign of the inequality is not going to flip. So that means we have square root of A, B, C, D greater than B, C. Now what we'll do, we'll square both sides. Squaring is not going to affect the inequality sign. So we have A, B, C, D greater than B squared, C squared. Since we have already considered B and D to be positive, so what we'll do, we will divide both sides of the inequality with B times C. So we'll divide both sides with B times C. And this is going to give us A times D greater than B, C. So we have proved the second inequality as well. That means AD is going to be greater than BC. Now let's move on to the third inequality. So we'll start with the given condition. So in our problem, we are given that A, B, C and D, that these 4 numbers are in harmonic progression. The sequence is in harmonic progression. So what we'll do, we'll consider only the first 3 terms. So A, B and C, these 3 numbers are going to be also in harmonic progression. If they're in harmonic progression, then we can also say that A raised to the power of n, B raised to the power of n and C raised to the power of n, they are in harmonic progression as well. Now we can say that B raised to the power of n, so this is the harmonic mean of A raised to the power of n and C raised to the power of n. But we know that B raised to the power of n, that means if B raised to the power of n is the arithmetic mean of A raised to the power of n and C raised to the power of n, then the arithmetic mean will be given by A raised to the power of n plus C raised to the power of n divided by 2. And we know that the arithmetic mean is always greater than the harmonic mean. So the arithmetic mean, which we have defined as A raised to the power of n plus C raised to the power of n over 2, this is going to be greater than the harmonic mean, which is B raised to the power of n. Now in the final step, what we'll do, we'll multiply both sides of the inequality with positive 2. So we get A raised to the power of n plus C raised to the power of n on the left hand side, and on the right hand side we have 2 times B raised to the power of n. But 2 is a positive number, so the inequality symbol is not going to flip. So this is the proof. So we have also showed that A raised to the power of n plus C raised to the power of n, that's greater than 2 times B raised to the power of n.